All right, 10.3. Find the measure of the red arc or chord. Well, again, it's hard to see on yours, but this is the one they're talking about right here, this arc right here. Since these chords are marked the same, okay, that means the central angles are the same also, so 75 degrees. So the measure of AB, or we put a little eyebrow on it, is 75 degrees. Okay. Now this is really hard to see because it's so tight of a picture, but since this is 34 degrees and this is 34 degrees, and this little chord is 5, that means UV is 5 also. So kind of blow this up. What they're saying is, you know, that line is 5, that line is 5 if these are both 34. I'm just kind of blowing that up so you can get the idea, but that's what we're talking about. Right, number 5. The red arc is this one right here that I'm drawing in blue, ironically. Okay. So now you might be thinking, oh, WY is a diameter, and so why don't these add up to 180, 160 plus 10? Well, if you notice, it's not a diameter because it is not going through the center. Okay, so it's a little bit off. Everything's a little bit off. The center is kind of right in the elbow of that little angle right there. So it's a little bit different than it looks like at first from quick glance. Okay, so this one can be a little tricky because we're looking at the congruent corresponding chords theorem. So let's just pretend, just make up some numbers. Let's say this was 5 and this was 5, and this was 10 and this was 10. Okay, that means this is 15. Okay, if that's 15, that means, hold on, and then this is 15. What that means is if those chords are the same, this arc right here is going to be equivalent to this arc. All right, so they have an overlapping section right here, which is 60, which means the other section, this has to be 110. Okay, and then if you add up those numbers, and people go, oh, those two are 110, so these are both 60. That's not the case. You can tell that this right here is obviously larger than the other one, but also if you add 110, 110, 60, and subtract from 360, then you will find out that this is 80. Okay, so very common mistake there, and you just gotta go step by step. Now, when I asked for the red arc, that was right here. So that was X, Y, Z, and that would be 170. Okay. All right, then over here, since this is 120, we're trying to find the red, which is right here. Okay, so if that's 120, and this is also 120, that means this must also be 11. So QR is 11. All right, now we're into the perpendicular chord bisector theorem. Okay, so when we have these two chords, okay, well, the diameter is perpendicular to the chord. That means it is a bisector. So that means X is 8. Okay. Again, over here, we have a chord that's perpendicular to the diameter, which means this is equal to that. Well, if that's equal, that means these two are equal, so X is 40 degrees. Number 9, again, we have a perpendicular line between the chord and the diameter, so that means this equals that. So we literally just say 2x plus 9 equals 5x minus 6. So I'm going to minus 2x I'm going to add 9. No, I'm not. I'm going to add 6. That was silly. Which is going to give me 3x equals 15. And when I divide by 3, I'm going to get x is 5. Number 10, again, these are equal to each other. So I'm going to subtract 5x. Again, I like to keep my x's positive, which means I'm going to add 12. And that gives me 2x equals 14, so x is 7. Number 14, determine if AB is the diameter of the circle. Okay, so we need the measurement of this right here. Okay, well, we have a right triangle. 5 is the hypotenuse, so we have 3 squared plus b squared equals 5 squared. Hopefully you recognize this as a Pythagorean triple. B is 4. So this is 4 right here. So the answer is no, okay? Because if that was a diameter, if AB was a diameter, then CD should be bisected. So CD is not bisected. So those two chords, the two parts of the chord should be equal if it is perpendicular to the diameter, and it's not. All right, 15. On this one, basically, if they're perpendicular to the equal lines, then these two are equal. So I'm just going to write that equals that. Subtract 4x. Again, I like to keep those positive. Add 6, add 6. Whoops. So 7x minus 4x is 3x. I did not mean to cross those off. Equals 9. So x is 3. Now it says find the radius of Q. So this is the tricky one where you have to draw the triangle in right here. Okay. Now what we just found out was if we plug in 3 right here, 7 times 3 is 21, minus 6 is 14. Or, if I could do math, that would be 15. Okay. And we know since this is 16 here, that makes this 8. So we're trying to find the hypotenuse. So what we have here is a triangle like this. This is 8, this is 15, and we're trying to find this. So that's 8 squared plus 15 squared equals c squared. This is also a Pythagorean triple. And if you do the math, c ends up being 17. And that is the radius also. And then number 16 right here. Again, since the distance here is 5 and 5, that makes these two chords equal. So 4x plus 4 equals 6x minus 6. I'm going to keep my x's positive. Add 6. So that gives me 10 equals 2x. So x is 5. Now again, we're trying to find the radius, which would be right here. Okay, so it's very thin right here. We know this is 5. Okay, we plug 5 in here. We have 5 times 4 is 20, 24. That means this whole thing is 24, which makes this 12. And we're trying to find c here. So again, we would do the Pythagorean theorem. 5 squared plus 12 squared equals c squared. Another Pythagorean triple. C is 13. So my radius is 13. That's it.